All right, so we're going to start the backside of your section 2 notes. At this point, you should feel very comfortable using your molar mass as a conversion factor, and you should feel very comfortable calculating your molar mass. Probably like a 4 or a 5 on a fist to 5 scale for calculating molar mass, and at least a 3 for using it as a conversion factor. So far, we have on this beautiful little flow chart that we know how to convert between grams and moles. This is what we have learned. Next up, we're going to learn how to convert between moles and particles. Remember how I told you that moles represented a certain number of particles? Well, here's that certain number of particles. The last step is an optional step, where we can do a shortcut to go straight from here to here. I'm also going to be able to do this in a 2-step problem, which is what I personally prefer, but I don't care what you guys do. If you want to do a 2-step problem to get from moles to particles, or if you want to do a 1-step problem, that is up to you, whatever makes you feel comfortable. So the first thing you're going to do is you're going to read this first line. Since the molar mass of a substance is equal to 1 mole of particles of that substance, we can use it as a conversion factor. So moles, molar mass, go ahead and write your conversion factor from the first page right here. Remember that the molar mass is a quantity that you actually have to calculate. So that's a number that every single time you need it, you're going to have to calculate it. So far, every time we see the unit moles, we have always had the number 1 with moles. We've only ever seen what happens when we have 1 mole. Next week we're going to change that, but for now, every time you see moles, it should be with the number 1. Okay, moving on up. Since 1 mole of a substance is equal to 6.022 times 10 to the 23rd particles. Now let's pause there. I just gave you another conversion factor. 1 mole equals this amount of particles. Remember we said mole was kind of like a dozen means 12? Well, mole means this big massive number. We call this Avogadro's number. And I always make sure that I use parentheses when I encounter scientific notation in my calculator. So always put parentheses around scientific notation. Otherwise, sometimes your order of operations get kind of messed up. So Avogadro's number is the 6.022 times 10 to the 23rd particles. Particles can be anything really. It's specific to what you are talking about. If I am talking about a compound, like NaCl, a compound exists in molecules. So it's a molecule together. I'm going to use molecules as my particles. But if I'm talking about an individual element, like copper, like a sheet of copper, then I'm going to reference the number of atoms because copper doesn't exist in molecules, it exists in atoms. So I have told you that 1 mole is equal to 6.022 times 10 to the 23rd particles. Let's use that as a conversion factor. I could also do 1 mole on bottom and 6.022 times 10 to the 23rd particles on top. This is the conversion factor I'm going to use on these problems down here. Let's go ahead and do this last problem here. So in this case, I am going to be solving for moles, and I am given the number of atoms. Notice that it's atoms because I'm talking about an element. Atoms really are the number of particles. So we are starting here on our flowchart and we want to go to here. That is a 1-step process. Boom, boom. So start with the number given. times 10 to the 23rd. I can't see that, I am blind. 22nd. And we are going to use this conversion factor because we want particles on bottom. With 1 mole on top. So we have 1 mole and we have particles. That should say atoms, I guess. Atoms. Either way, it's still pink. Okay, in your calculator, this is the tricky part. Most people can set this up correctly on the test, but then they biff it on the calculation because they plug it into their calculator wrong. So make sure that you are actually practicing plugging it into your calculator. So I'm starting with parentheses. 1.25 times 10 to the 22, that's 55. 22. And you are going to divide that by 6.022. This is really hard to do under the doc cam. Times 10 to the 23rd. So in this case, I have 3 sig figs here. I have 4 sig figs here. I'm going to round this guy to 3 sig figs. So it's going to end up being 0.0208 moles of carbon, and that is my final answer. Okay, if you are feeling confident, go ahead and move on to these 3 problems. They are